In this video, we are going to learn how to calculate masses from the electrolysis of copper chloride. Electrolysis is a process by which ionic substances that have been dissolved in water or melted or decomposed broken apart into simpler substances when an electric current is passed through them. For example, if you were to take molten copper chloride, it would be broken down into copper metal and chlorine gas. It is possible to calculate the mass of the copper produced from this electrolysis. There are two main ways that this can be done. At this stage, you should be aware of three key facts. Firstly, for any given substance, 1 mole of molecules is equivalent at a relative molecular mass of a substance in grams. Secondly, 24 decimeter cubed of a gas represents 1 mole. And thirdly, the number of electrons transferred during the electrolysis dictates the ratio between reactants and product. For this example, the electrolysis of molten copper chloride is shown as two half equations, one for the oxidation and the negative electrode and one for the reduction at the positive electrode. What do you notice about the number of electrons transferred in both reactions? Pause the video and resume when ready. There are 2 electrons being transferred in both processes. As a result, there is a 1-to-1 ratio between the copper and the chlorine gas. So for every 1 mole of copper produced, which is 63.5 grams, it produces 1 mole of chlorine gas, which can be thought of as either 24 decimeter cubed or 71 grams. Also, when these masses are combined, this represents the formula mass of 1 copper chloride unit at 134 grams. Here is a challenge for you. If we were to use half the number of moles of copper chloride, then A, what mass of copper would be produced, and B, what mass of chlorine would be produced. Pause the video and resume when ready. The answer is that because half the mass of copper chloride was used, then half the mass of copper is produced, that's 31.75 grams. Also, half the mass of chlorine gas is produced, so that's 35.5 grams or 12 decimeter cubed. There is a second way of calculating the mass produced from electrolysis reactions. This involves the use of this formula where Q is charge or number of electrons in coulomb, I is the current in amps, and T is a time in second. 1 mole of electrons has a charge of 96,500 coulomb, also known as a Faraday. Let's say that the mole copper chloride is electrolyzed using the current of room temperature for 1 hour. Using this information, we can calculate the mass of copper produced. You might want to have a pencil and paper ready for the next part. Pause the video and continue when ready. Step 1. You can use the formula to work out the quantity of charge passed in the time given. Remember, there are 3600 seconds in 1 hour. In other examples, you may have to convert to seconds. Try and work out the charge transfer. Now, it might make it easy if you write it out in form. Pause the video and check your work in answer when ready. You should have got 7200 coulomb. Step 2. Using the equation from before, you should recall that 2 moles of electrons are transferred, so there is a relationship between the number of electrons transferred and the molar mass of copper metal, which is that for every 2 moles of electrons transferred, 1 mole of copper is produced at 63.5 grams per mole is its molar mass. Remember, 96,500 coulombs represented every 1 moles of electron transferred. We next need to find the number of moles of electrons that were actually transferred in our reaction. This you can do by dividing the answer from step 1 by 96,500 coulombs. Do this now and resume the video to check your answer. You should have got 0.0746 moles of electrons. Remember, though, there is a ratio of 2-to-1 electrons transferred to moles of copper metal produced in a reaction. So, to find the actual moles of copper, you have to divide 0.0746 by 2, which is 0.0373 moles. Now we know how many moles of copper we have used, and that 1 mole of copper has a mass of 63.5 grams. You can obtain the mass of copper produced. Try it now, pause and then resume the video to check your answer. The answer is 2.37 grams. In summary, there are 2 ways you can calculate masses from electrolysis reactions. The first uses reacting masses and ratio. The second involves the use of the fact that 1 mole of electrons has a charge of 96,000 1500 coulombs. Using this fact and formula Q equals I times T, you can calculate the actual charge being transferred in a given time. Knowing this and the molar mass of the element in question allows you to use proportion as shown from the example to calculate the mass of any unknown from an electrolysis reaction.